So, good afternoon, everybody, and welcome to this, our first pollinator of 2021 and Agri-TechE's second event of the year. So, some of you were with us for Agri-Tech Express last week. So this is a bigger event in a bit more detail, a bit more depth, and we're going to be talking about keeping it clean with Agri-Tech innovation. So hopefully, I think most of you on the call will know about Agri-TechE. We do have some non-members with us today, so you're very welcome. It's a pleasure to meet you, and I hope our paths cross in person at some point soon. So just a reminder, Agri-TechE is a membership network. We are really an innovation ecosystem, bringing together those farmers and growers with the technology developers and the researchers to build this kind of community to help develop and bring new innovations out, almost literally into the field. So we're independent, we are private sector, so we don't have core government funding. We exist for our members and to help really raise awareness and to get that conversation going about new connections and new innovations. So those of you who aren't members, if you don't already sign up to the newsletter, please do. You can do that free. And if you're not members, we'd be delighted to have that conversation with you as well. But please do stay in touch. This is hopefully the start of the conversation, which will carry on. So a little bit of housekeeping. I think everybody's horribly familiar with this format now of online. We will be tweeting throughout, and the Twitter handle and the hashtag should be in my signature at the box that you're looking at me through now. If you are registered for basis points, then you can collect 1 point, and Fiona will put the link in the chat for you to be able to register with your basis account number, and we will ensure that the point gets added to your account. A little bit of clarification for the delegates on the call today. Please do keep your cameras off and your microphones off, but if you would like to ask any questions, please do so using the chat box. So I will keep looking at the chat, and I will endeavour as far as I can on your behalf to ask questions of the speakers for you. So please keep those questions coming, and we'll do questions of clarification after each of our 3 speakers have spoken. Then we will have a little break and replenish our glasses, and then we'll come back for more of a panel session where you will see all the speakers in plenary, and then we'll have a bit more of a chat in a bit more detail. So the topic of today's pollinator is around keeping it clean, and oh my goodness, has ever there been a time where we've talked about almost nothing but removing contamination and microbes and keeping things safe and clean. So this may seem a new conversation to a lot of people not in the sector, but in the agri-food industry, obviously managing pathogens and spoilage organisms and keeping things fresh so that they are less susceptible to attack by those spoilage organisms is really front and centre of what's keeps people awake at night, almost literally. We're really excited today to have 3 speakers that are talking about some really exciting new innovations, and we have an exclusive product launch from one of our speakers as well. So hopefully there will be some things that you absolutely won't have come across before. So I think without further ado, we should get going, and I would like to invite our first speaker, which is Ralph Weir, who is the director of Zaindu, to please join me. Hi Ralph, nice to see you, you're very welcome.
Hi Belinda.
So may I invite you to share your screen, and we'll hear about Zaindu. Thank you.
Thank you. So, thank you, Belinda, for the nice introduction. I'm the CEO at Zaindu, and we're talking about an organic and non-toxic seed sterilisation system. And you see the 3 key bullets down at the bottom of we're doing seed sterilisation, seed disinfection without chemicals, without water, without leaving any residues. So it's very environmentally friendly, very ecologically friendly. But more than that, it's got very low operating costs. So it's actually, there's something there for everybody in the seed processing industry, whether you're on the biology side or on the finance side. So a little bit of background. What's been going on in agriculture is for some time now, we've been relying on chemicals to control pathogens both out in the fields and when we produce seeds. So we bring seeds in from the fields, we disinfect them, which means that when they're sown, we're ensuring healthy plants and good yields. But these chemicals cause a lot of damage to the environment, and as a consequence, many of them are being legislated out. The other thing that's going on is that some seeds can't be treated chemically in any case. Things like fast-growing salads, there isn't perhaps enough time for the chemicals to guarantee for the chemical to dissipate. Equally, many of the chemicals are applied as a wet spray, and so for many seeds, that has very devastating effects on germination. So there's some real challenges here, and it's not something that's going away. The EU's Green Deal is aiming to reduce pesticide use by 50% through this decade, and also to drive the use of farmland for organic production to something like 25% of the area of the EU's farms. So it's an ongoing trend, and we're seeing this all around the world. So the solution that we've come up with is based on cold plasma disinfection. Now, this is a unique and patented process. It was actually originally developed at Loughborough University and has been in development for about 10 or 15 years, in fact. The cold plasmas will kill most of the nasties that they come across, so fungi, bacteria, even right through to viroids. So a very strong disinfectant approach, and yet organic and low energy. One of the really key things with what we've been doing, though, is to take this cold plasma technology and make it applicable to the seed production environment, to make it something that you can use in a factory and to be dealing with large quantities of seeds, not just a few teaspoonfuls of seeds, but larger quantities, the sorts of things that actual commercial seed producers are interested in. So what it looks like then is it's actually something that's very familiar to a seed producer. Is a lot of seed processing revolves around drums. So we put seeds in a drum, nothing fancy in there, just air, which is at room temperature and room pressure. And we then apply a plasma, and hopefully if I run this, I can get a little video running. I'm not sure how many of you will be able to see that. But we tumble the seeds around. The plasma creates activated air, which is a high energy form of air. We've just taken the air, put energy into it, and created something which is a very strong disinfectant. There's a lot of process control going on to try and ensure repeatability of the process. But what's really interesting is at the end of the process, we take the energy back out of the air. And that means that the activated air quenches itself back to normal air. There's no residues left in the seeds. And what comes out of the drum is normal air, might smell a bit of seeds, but normal air and disinfected seeds. Oh, so what is in activated air is actually a blend of what we call RONs, reactive oxygen and nitrogen species. So I think we'll talk a little bit about ozone in some of the later conversations. What we've got here is a blend of ozone, also atomic oxygen. So where ozone is O3, it's a larger form of the oxygen molecule, as it were. Atomic oxygen, O on its own. We also have ultraviolet coming from the plasma source and various forms of nitrogen gases. And all of these things are things that attack viruses, bacteria, fungal spores, and are very, very effective at removing them from the seed coat. And as we've said, no chemicals, no heat, no vacuum, no noble gases, and it all goes back to being just normal air that you can breathe at the end of the process. An example of how we would prove this works is you take a batch of seeds and treat some, use some as a control sample, and incubate them to see what happens. This is what we got from wheat, which was untreated and incubated through the incubator that we just saw. And the fuzziness that you're seeing above the seeds there is fungal contamination. So it's a very heavily contaminated seed sample. Here's what happened with the treated batch. And you can see the very, very clear difference. The treated batch, there is no fungus, but the other thing you'll notice is the number of seedlings that are involved. These were taken at the same, they'd been incubating for the same amount of time, and we were seeing something like a 4 times increase in the germination rate. This is early germination. So this is a fantastic metric of the vigor of the seed. This is something that is very, very useful for establishing crops early, for getting the most biomass out of a seed in the end. We're seeing similar results across all the seeds that we've trialed. The sorts of things. Oh, sorry. So this is an example of the sort of thing I'm talking about, where we are treating rocket, in this example, a fast-growing salad leaf, and untreated, the germination rate was about 78%. With treatment, it rose above 80%. So this is decontaminating them. It was at a higher germination rate. And the germination rate kept climbing as we increased the treatment dosage, far beyond what was required to disinfect these seeds. What was really interesting was we actually tried to kill these seeds, and we couldn't. We still had a higher germination rate than the untreated seeds. So very interesting that we've decreased or eliminated the contamination, but we've also increased the germination rate. So it's a fantastic combination. Here's some examples of the sorts of crops that we've been working on. And you'll notice there's a bit of a bias really towards the smaller volume, small batch size crops, the higher value crops. Of course, that's natural in the way you take a process like this out to the market. It's nice to start with something manageable before you scale up and build very, very large machines, but that's very much part of our plan. It's actually quite difficult to source contaminated seeds. So this work has to be done in collaboration with the big seed producers. We can obviously artificially contaminate seeds, but then they're not representative. So we've been working with the big seed producers, finding the seeds that are coming into them with contaminations perhaps that they can't cope with, sharing our germination and test protocols with them, allowing them to verify the test results. And that's a program that's been going for a couple of years now and going very, very well for us. The next slide has a list of scary bacteria and fungi on it. My personal favorite is this Acidovorax, which sounds like it should be a Doctor Who monster, but there's a lot of very familiar things in there: Pythium, Phoma, Fusarium, Xanthomonas, and Pseudomonas. These cover the wide range of pathogens that seed processors have to deal with. We haven't found a combination of seed and pathogen that this system has been unable to treat. So we have a 100% success rate to date. And I think that's unique. I don't think any other chemical could claim that. This is the exciting bit. It's a product announcement. So this is our Z10 machine. And the 10 comes from the 10-litre treatment drum, which houses approximately 1 kilogram of seeds. It's geared towards processing the high-value seeds, as we mentioned a moment ago, but it's also ideal for developing protocols that you would then apply in a larger machine. Perhaps if you wanted to treat carrots, for example, where the throughput may be something like a ton of seeds per day, this machine is far too small. But you can prove the protocol on a small sample of seeds, develop it, get it spot on, and then roll it out onto the production line for a larger machine. There's a fair number of these machines have actually gone out to universities and alpha sites. We're now opening it up a little bit wider towards early adopters, the wider community who are interested in getting involved. We've got a level of maturity that means we can really effectively support the machine out there. Although we are saying that as this rolls forward, we'll continue to apply upgrades and updates to the machines as we progress. That's obviously the first point in our roadmap. The next machine down the line is the 100-litre machine, and that's due out in the summertime. It's actually currently operating in the lab. We're actually fitting the plasma power sources and so forth to it and starting to verify and characterize its performance. Second half of next year should see a 600-litre machine, and then a 2,500-litre machine for the following year. These are for seed processing equipment. They're relatively expensive machines, but the interesting thing is we're setting pricing calculated to really provide a significant advantage in terms of the operating costs. And the way this is achieved is like this. The conventional approach to non-chemical seed treatment is through hot water treatment. And you can see it's coming in at something like 65 pence per kilogram. You'd expect the little lab scale machine to be more expensive. It's only treating a kilogram at a time, but it's half the cost. And the larger machines are cheaper still. And of course, that really brings in this emphasis on there's something here for everybody, whether it's the people growing fast-growing salads, the people who have to replace thiram, the people processing mucilaginous seeds, or the finance director who's worried about the overall costs. This is a winner all round. At this point, there's two main options for early adopters to get involved. The first option is to get a machine on site and evaluate it. So we're providing these either on a short-term rental or as a purchase, and doing a lot of hand-holding with that, supporting it with installation, training and so forth to ensure success. The other thing is that we are very happy to accept seeds for treatment, not as a service. We're hoping that we have several partners who will provide a seed treatment service as a pay-for service. But what we're very interested in is taking seeds from people to prove the capability, to perhaps explore a crop that we've not tested before, or a pathogen that we've not seen before, which improves our knowledge and also proves the capability of the process. So to wrap up at that point, there's my contact details, and if there are any quick questions, I'd be very happy to take them.
Ralph, thank you so much. Golly, have we not heard about this before? This is amazing. So a question of clarification, let's get it out of the way, about safety. There's some pretty heavy duty physics going on and chemistry with all these free radicals zipping around. Talk to us about safety.
Yes, there are two aspects to that, of course. There's the basic safety of the machine itself. So there are fairly high voltages and currents and frequencies involved in running the plasma generators. That is all tightly controlled, and there are many safety lockouts on the machine. Mechanically around the machine, we've looked at how you provide safety to the operator around a large rotating barrel. I don't know if you noticed on the image of the Z100, there's actually a perspex cover over the whole thing, so you can't get close to any of the moving parts. So in terms of the electrical and mechanical safety, we've put a lot of thought into it.
Right.
I also talked about the quenching of the activated air. The reality is that those gas species that we have in there are at many orders of magnitude higher concentrations than you would experience in everyday life. And so the shutdown process of the machine, regardless of how you shut it down, if there's a power cut or whatever, when it resumes, it goes through the whole quenching sequence, and it's looking at its gas sensors going, are we back to a safe level before releasing this? So we've tried to think through both aspects, both the aspects of the chemistry, what happens if there's a power cut, what happens if somebody just tries sticking their fingers in places they shouldn't go, try to cover everything. And of course, the machines are going through things like CE marking to get the official stamp of approval to say that yes, we have achieved that.
Sure. Okay, great. Do you want to stop screen share, Ralph, just for a second? I think everyone's got your phone number and email address, and I'm sure there will be a lot of interest in that after that lovely call to arms. Have you got any sense? Oh, you've turned your camera off.
I'm trying to figure out how to stop share. Oh, it's the big button marked stop share.
That's the one. Have you got any sense of what's going on biologically with that germination metric? Seeing, I mean, they really do seem to be quite a lot happier having had a good blast in the Aurora Z10. So is there any idea of what the biology is going on behind that?
It's a very interesting question. We don't have as much understanding as we would like. It is opening up some additional pathways within the seed. It is thinning the seed coat also, both of which are probably helping the germination response. It's an area that we can see the effect, and we can also model the long-term shelf life of the seeds and so forth, and confirm that we're getting good results out. But we haven't as yet really understood all of the pathways that are involved there. It's a really interesting area.
Great. Ralph, we will be coming back to you in the panel session. Still so many questions to ask about this, but for now, could I thank you and ask you to turn off your camera and mic, and we'll see you in a bit. And in the meantime, can I invite Debbie Rees, please, to join me. Hi, Debbie. So Debbie is from the Produce Quality Centre at the Natural Resources Institute, which is part of the University of Greenwich. And Debbie, I think it's fair to say your life's work is around fresh produce and extending the shelf life and understanding the quality and keeping it safe and fresh and clean for as long as possible. Is that fair?
Scarily, I think that's a fairly accurate description, yes. Some 27 years of this so far.
So we're going to be hearing, Ralph mentioned ozone, and we're going to be hearing about ozone and the superpowers that it conveys to fresh fruit and veg. So can I invite you to share your screen, and over to you, Debbie. Thank you.
Okay, well, thank you, Belinda, for the introduction. So as Belinda says, I'm a scientist. I work at the Natural Resources Institute, University of Greenwich. And today I'm going to talk about work that we've been involved with looking at gaseous ozone.
Sorry, Debbie, can I just, your sound has gone again. So whatever it was you did in the practice, to just soften it. It's gone again. We can hear you, but it's still a little scratchy.
Can you hear me now?
That's better.
Okay. Just tell me if you lose it again in any way. So I work at the University of Greenwich, Natural Resources Institute. As an institute, we work across the globe on agriculture, and with a particular interest in fresh produce supply chains. We have a post-harvest research unit, the Produce Quality Centre, which we manage, which is based on the same site as NIAB EMR, with whom we work very closely. Okay, so I'm going to talk about ozone. In some ways, Ralph's description, the technology that he was talking about involves ozone to some extent, but what I'm talking about is more the pure use of gaseous ozone. Ozone is one of the most powerful oxidants on Earth. It is chemically, it's O3. So whereas gaseous oxygen is O2, ozone is formed from the O2 oxygen molecule. It can be formed in two ways. It can be formed by the reaction with UV light. It can be formed by electrical discharge. So in the atmosphere of our planet, ozone is formed by UV from the sun, forming the ozone layer at the top of the atmosphere. But for commercial use of ozone, it's more usual to use electrical discharge because we can form much higher concentrations of ozone from gaseous oxygen. So it's very reactive. It has a short half-life, which is even shorter when there are chemicals around, organic chemicals that it will react with. So essentially, because it has therefore such a short half-life, essentially treatment with ozone is a residue-free treatment. Okay, so as a very reactive molecule, it will react with pretty much all living organisms and inanimate objects. So, for example, ozone is very effective in killing bacteria, fungi, molds, and viruses. Very topical right now. We know that ozone is very effective at inactivating SARS, and more importantly for us at the moment, inactivating COVID-19. That's not what I'm going to talk about today, though, but useful to know. So as a killer of bacteria and fungi, gaseous ozone can reduce rotting of fresh produce and thereby extend shelf life. However, it will also react with the fruit and vegetables that we're trying to protect. So the amount of damage to the surface of fruit and vegetables is very dependent on the type of tissue. So for example, leafy vegetables are much more sensitive to damage from ozone than fruits. So what this means is that when we are trying to use ozone to protect against pathogens, we have to optimize the treatment so that we balance the killing effect against the pathogens, but minimize any bad effects on the produce. Interestingly, there are cases where ozone can actually improve the quality of the fruit and vegetables. But ozone can also be damaging to humans. And in particular, ozone will damage the lining of the lungs and so can cause breathing difficulties. So of course, ozone treatment protocols and equipment must be designed to protect personnel. The recommended exposure for humans is less than 200 parts per billion. Ozone will also react with inanimate objects. So there are certain materials that are particularly sensitive to ozone, in particular rubber, nylon, cast iron, and to some extent steel. But there are resistant materials, including Teflon, stainless steel, and silicon. So when we're designing equipment for the use of ozone, must be designed to be resistant to damage by the ozone itself. So I'm going to talk about 3 ways of using gaseous ozone for the fresh produce industry. 3 ways to do this, all of which we as scientists have been involved in testing with our commercial partners. So the first of these is continuous low-level exposure in stores. Second, decontamination from human pathogens of minimally processed produce. And thirdly, more recently, we've been looking at flushing of retail packs with higher levels of ozone. So basically what I'm starting off with is presenting some of the, very briefly, some of the experimental results that we've obtained when looking at the effect of low levels of ozone long-term during storage. We're talking about levels in the parts per billion. So for example, here we have red chili peppers, where by increasing levels of ozone long-term, we have been able to reduce the incidence of rots. So we found that in laboratory trials, if we exposed chili peppers to ozone at 450, 900 parts per billion, we reduced the rates of rot. But interestingly, we saw that if we went to higher concentrations, it was less effective, basically suggesting that we were getting direct damage to the chili peppers. So remember earlier I said we would have to optimize the treatment. This is an example of why we have to do that. We got similar results with grapes. And here again, as we increased the rate of treatment, initially we saw very good control of rots. And then as we went to higher levels of ozone, we saw less good control. So again, the conclusion is that we are actually damaging the grapes if we take the ozone too high. But as I mentioned before, interestingly, in some cases, we see some positive benefits to the produce itself, regardless of rot control, by the treatment with ozone. So for example, with cucumbers and courgettes, we found that long-term low levels of ozone could actually slow down water loss and slow down shriveling. So this is a bit confusing. We believe that this is probably because ozone has a direct effect on the stomata which are the pores in the surface of the cucumbers and the courgettes, through which you get gas exchange and water movement. Okay, so what does this mean in practice then? So our laboratory results look positive. Does this transfer to the commercial situation, which after all is what we're really interested in? So there are a number of companies across the world which are using ozone treatment within stores. It's routinely used for organic apple storage in the US and in many stores within the UK, especially for produce like tomatoes, cucumbers and peppers. We know that it's very effective at reducing the fungal spore load, both at reducing the rots and also at reducing the fungal spore load in the atmosphere. But there are some reports that the results are not as positive as seen in the laboratory trials. And frankly, there is a challenge that we still haven't managed to address of ensuring that ozone is distributed evenly across a store and within pallets for fresh produce. Okay, moving on to the second application that I talked about, which is to decontaminate produce of human pathogens. So we did some work looking at the possibility of using ozone for minimally processed strawberries in order to decontaminate. Experimentally, what we did was artificially contaminate with both E. coli and Salmonella, and then see how effectively we could remove it. So what we found was that ozone is very effective at removing those pathogens. Comparing it to the other standard of using chlorine wash, it was more effective in our hands. And it has the added advantage that without the water, we wouldn't therefore be promoting rotting. However, as I mentioned before, ozone can be damaging to leafy tissues. And in this case, at the levels that we were using, and the red arrow is to show you that we were using parts per million, which is 1,000-fold higher than we were using in the previous trials, we do in these cases damage the calyx. For this particular application, no problem. It was minimally processed fruit for which the calyx would be cut off anyway. So success there. The third application that I wanted to mention was a recent project that we have been involved with, led by Ozone Industries. And here the concept is to flush retail packs with ozone at a high concentration. So again, we're talking about the part per million levels at the point of packing. With the very short half-life that I mentioned before, within 30 minutes, there would be no ozone whatsoever detectable within the retail packs. So we've been struggling, but managing to do trials through lockdown, and we're getting some initial very promising results. So preliminary data indicates that ozone flushing produces a significant extension in strawberry shelf life. If the table in the middle of this slide makes sense to you, basically what we were doing was monitoring the individual punnets and scoring them for 3 is a pass, 2 is a pass, 1 is a fail. And we found that with ozone treatment, for longer, we would get more punnets within shelf life credentials, let's say. So we were getting an extension of shelf life. So just to recap, I've looked at 3 different situations here: low-level exposure, long-term in stores, decontamination of minimally processed produce, and our new application of flushing of retail packs. I hope you could hear me well. Thank you very much for listening.
Thank you, Debbie. That was great. We did have 1 or 2 sound issues, so we'll have a chat with you in the break about just having another quick sound check. But for now, if you could stop sharing your screen, but stay with us, please, in terms of a couple of questions of clarification. So you talked about, in terms of generating the ozone, applying an electrical discharge. I mean, these apple growers in the US, they're going to need a lot of ozone. How how easy is it to generate and handle this at scale, and what sort of costs are we looking at to add on to the processing costs?
Whoa. Good question. I can't at the moment give you an answer for the overall costs for treating the apple stores. Generally, the method for doing this would be to concentrate the oxygen within the air using filters, and then applying an electric current across that. I can't give you the costs for that at the moment. But
it's not prohibitive because they're using it commercially, so it's not prohibitive.
Exactly.
Yeah. Okay. And the other question was, so ethylene is used to delay ripening. Are there any examples where ethylene and ozone, I can't even imagine what the chemical formula would be for those two meeting each other. Are you able to use those in combination? Have you looked at that? Is it incredibly dangerous and will cause an explosion?
Okay. So it's a very interesting question, because early on, when a few years ago, when they first promoted the idea of using low levels of ozone within stores, one of the rationales was that it would remove ethylene. Ozone and ethylene react, and ozone will remove ethylene. So actually, ozone can be used in ethylene scrubbers in some cases. However, at the low levels of ozone that you use in stores, if we're talking about parts per billion, it's not effective in removing all the ethylene from the store.
Yeah.
So there's nothing dangerous about putting ozone and ethylene together. But it's not a very effective ozone scrubber if that's what you wanted to do. I wouldn't generally put ozone in a banana ripening room if I wanted to apply ethylene. But I don't think anyone's actually tested how big an impact it would have.
Right. Okay. I've been trying to write down the formula, and there's lots of H's and O's and C's around the place, which so it's possible no disaster would ensue, but it's not commercially practical or sensible, is what you're saying, really.
No disaster. Ozone can be used to scrub ethylene, but usually within a specific scrubbing chamber.
Brilliant. Debbie, thank you so much. Please stay with us, but can I ask you to turn off your camera and mic, and we'll see you a bit later. And now it's my pleasure to invite David Goosey from Ozone Innovations to join us. David, nice to see you. Thank you for being part of this afternoon's event. And well, Ozone Innovations has been a member of Agri-TechE for a long time. We're very proud to have you as a member, and really excited to hear you go. I think we're moving a little bit down the value chain into processing, aren't we? So
that's right.
Over to you.
Thank you very much, and good afternoon to everybody. It's a pleasure to be here this afternoon. We are indeed going to move a little bit further down the value chain and look particularly at food processing, but it's worth mentioning that there is potential for the technology I'm going to talk to you about today further up the supply chain in meat and produce transportation and sort of primary processing. Let me start by sharing some of the context for what we're trying to do, much of which I know will be familiar to people on this call. To start with, the UN forecast that the global population is going to grow to 10 billion by 2050. And another fact that fascinates me is that by then, up to 70% of us are likely to be living in an urban situation. And I think that's significant because those of us living in an urban and increasingly in a megacity environment are going to be far away from the land and the sea where the food that we need is produced, which is going to place an increased reliance on food processing to provide reliable access to the safe and nutritious food that we all crave. The food industry is a significant drain on water and energy, if you'll pardon the pun. And just in the UK, for example, food industry accounts for 14% of energy consumption by businesses and 10% of all industrial use of the public water supply. And all food manufacturers are looking for ways to reduce their carbon footprint. And the hygiene process in food manufacturing is one area that offers the potential for significant reductions in the consumption of precious resources. As an industry, we need to work together to find ways of reducing the impact of food production whilst trying to balance the need to feed a growing and increasingly urban population. And I understand that according to CIEL, we currently only have insight into technologies and methods that would enable the farming, agriculture and food industry to deliver less than 20% of the carbon reduction goals set by the Committee on Climate Change. If we look at the consumer, expectations are increasing around the sustainability of food, putting pressures on the entire food supply chain to adopt more responsible and sustainable practices. And I was fascinated to read the Waitrose Food and Drink report a month ago, which cited that 60% of us want UK businesses to bring forward our carbon net zero commitments. That was in the future of British farming section of the report. As we look at the impact of those changing consumer demands and the increased awareness that all of us have of the impact of our food choices on the world around us, there's a big impact on the food supply chain and food retailers. According to The Independent, nearly 1 in 4 UK food products launched in 2019 were vegan. And this increase in consumer choice leads to more SKUs, more frequent line changes for manufacturers, and more complexity throughout the supply chain. And whilst the pandemic has caused unpredictable demand in the medium term, we're seeing an increased demand for food to go and ready meals, which require a high level degree of care in their production. And then the other growing trend we need to be conscious of is the growing prevalence of allergens and our sensitivity to them. The World Allergy Organization estimates that between 11 and 26 million people in Europe suffer from food allergies. If you scale that up globally, it's between 250 and 500 million people in the world could have a food allergy. That's way in excess of the population of the United States. And again, this puts increased responsibility on all of us in food retailing and manufacturing to control allergens as well as pathogens. And lastly, on the commercial side, you will all be familiar with the never-ending pressure on food manufacturers from the food retailers, particularly in the highly consolidated UK market, to sort of the never-ending squeeze on margins and the search for increased productivity and efficiency to enable food manufacturers and food producers to maintain or potentially even increase their margins. And the food hygiene process typically accounts to between 8 and 12% of food manufacturer operating costs. So it's an important source of efficiency if we can get after it. And with an opportunity to reduce resource consumption, increase operational efficiency and improve standards, we believe that hygiene is an area that can help businesses deliver these all-important savings. And this is where we come in. So we're Ozo, a growing business. We're based in the UK and we're focused on delivering innovative hygiene solutions for the food industry. We're backed by a global investor base, our major shareholders being the Wheatsheaf Group and Astia Angels. And we're focused on delivering safe and sustainable solutions that deliver really high standards of hygiene whilst conserving the resources that we've talked about. And we believe that our technology and hygiene solutions have the potential to help shape a more sustainable and cost-effective future for food supply chain. So let's have a look at how we go about that. So our electrolytic technology transforms salt and water into a powerful cleaner and disinfectant solution that we call EllaClear. EllaClear is generated in situ on site at the customer's premises by our EllaCube or EllaSystem equipment, which delivers EllaClear at ready-to-use concentrations of between 1,800 and 2,000 parts per million, and a pH of around about 8.8, and the ambient temperature between 20 and 25 degrees C. And according to our testing, EllaClear is effective against allergens and pathogens and has been independently tested for antimicrobial efficacy against bacteria, yeasts, fungi, mold, and viruses. And our unique data analytics platform, which we call Elo Inform, provides food manufacturers with real-time performance and consumption data, as well as monitoring of our Elo systems and Elo cubes to give the customers 24/7 control and visibility. And I look forward to the day where on our website, we'll be able to show people that are interested in how our systems are performing right across food manufacturing, not only within the UK, but beyond, and showing the amount of energy and resource savings we're able to generate. In a case study in a food manufacturer, our EleClear product was shown to have real potential. Cleaning with EleClear reduced the amount of water, energy and time consumed, with overall savings of up to 54% delivered in this particular example. In turn, wastewater and associated processing costs were also reduced, unlocking potential operational capacity because of reduced cleaning time. An in-situ production of EleClear can deliver a potential overall carbon saving of 80% through the hygiene process, largely because of the use of EleClear at ambient temperatures rather than the typical 5-step hot water process that the industry uses today. So we're committed to helping retailers and food manufacturers achieve net zero while driving productivity, improving margins and maintaining health and safety standards. Stricter allergen and pathogen control, sustainability, quicker changeovers for more efficient processes. Many companies are committing to UN Sustainability Development Goals, and we believe that we can directly impact 4 of these development goals, as well as delivering their greater productivity, improved hygiene outcomes, and improving the sustainability of the food supply chain. So we're aiming to make a real difference in an area that we think matters to each and every one of us. Our aim is to deliver smarter and safer hygiene solutions to the food industry and helping to drive productivity and maintain the health and safety standards in a sustainable way. And you can see my contact details here if anybody's interested in following up with me.
David, thank you so much for that. Wow, what a great journey this technology has been on. I want to just talk us through the sort of early inception. What's the journey that you've had to take this concept to get from sort of idea to where you are now, having these great case studies?
Thank you, Belinda. So I've only been with the business for coming up to 10 months, but what excited me about the business was the potential to really get after a problem that matters. And the challenge we've had over the time to get to where we are now is really a result of the sort of multifaceted nature of the operation. We've got the engineering challenge of designing and building and testing the equipment that manufactures the EleClear, that's our electrolytic equipment, making sure that that's fit for purpose, it can be easily installed in a customer's premises, and we've been able to reduce the cost of that equipment substantially over the various iterations. In parallel, we've been developing our understanding of EleClear and how it works in pathogen and allergen control, and of course needing to get the BPR approvals that are required to do business. And then although the core technology is familiar and has been around for many years, its application in food, we believe, is quite new. So really building our understanding of the food supply chain and the real day-to-day challenges facing food producers. So it's that multifaceted nature is a challenge we've been working our way through.
And is all the manufacturing done in the UK, or do you have offshore manufacturing capability?
So our focus right now is very much growth within the UK market, and the assembly of our products to support the UK market in the foreseeable future will be in the UK. As we get opportunities which are already coming our way through some of the food multinationals to do trials and explore the opportunities outside of the UK, I can envisage licensing or manufacturing agreements with companies outside the UK.
Right, and what would be your kind of wish list for Father Christmas for the business? Is it to scale more quickly in the UK, to get a foothold in those overseas markets?
It's funny, you made me think back to Christmas a few weeks ago. My biggest wish then was the pub would reopen. But notwithstanding that, no, real focus, and I think the challenge for any of us with these startup or scale-up businesses to get really good commercial traction. And our focus is very much on achieving that through the UK or in support of some of the multinationals that we're talking to. Once we've demonstrated we've got a profitable, robust business model, then I think the world is genuinely our oyster.
Sure. Okay. Excellent, David. Thank you. Thank you so much. So if you'd like to turn off your camera and just go quiet for a little bit. So we'll be taking a little bit of a break now, so you can go and grab a coffee and think of some questions as we move into the panel session. So we'll kind of zoom out a little bit. Obviously, there's still the opportunity to ask specific questions of our three speakers, but if we take a break, and maybe if you join us back just after the top of the hour at 3:05, and we'll invite all the speakers back into plenary as a panel session. So get those questions in throughout the break, and we'll see you in a bit. Okay, thanks, bye. So, hello everyone, welcome back. I hope you have a cup or a glass of something by your elbow to inspire you for some questions and thoughts through the panel session. So, may I invite our speakers to join me by turning on their cameras and their microphones, please. And we had a little bit of difficulty with Debbie's sound, so I know in the break she went out into another platform to talk to our colleague about fixing her sound. So why don't we carry on while we're just waiting? Ralph, I think you just turn your camera on, please. Sorry, your microphone. Thank you. Thank you, Ralph. Okay, so we have had a lot of questions to deal with. So lots of discussions. I've just heard Debbie's swapping PC, so she will be joining us when she's got a new piece of equipment. So, right, questions. Ralph, let's start with you. So, obviously, this afternoon is all about getting rid of the microbes that we don't want, but sometimes, particularly in an agricultural setting, there are actually microbes that we do want, and particularly beneficial soil microorganisms. So have you done any work looking at the impact that seeds that have had this treatment might have on the environment around the seed as it starts to germinate?
It's a really interesting aspect because, of course, as you say, what we are doing is eliminating all the bugs and so forth on the seed, which gives you a completely clean platform from that point on. What we're doing is we're working with some of the big seed companies on priming processes where they take this complete green field and add a new biome to it. And so, of course, that gives them the flexibility to introduce what they want at that point. But yes, it's a fair point that there may well be. Is it Yakult who say there's good bacteria, and we've wiped out all the good bacteria as well as the bad stuff. And so this approach of bringing in an artificial biome is actually something that's really interesting and something that we may well actually add to the machines over time as sort of a step forward.
Okay, and David, is there any potential for your technology to I'm thinking in maybe glasshouse environments to sterilize soil or whatever, if you want a clean, research condition soils, would your technology work on soils as well?
Yes, certainly in a lot of the controlled environments, the feedback that we're getting is up until now it's been possible to already sterilize the growing media. It's possible to sterilize the water and to sterilize the air on the way in. Sterilizing people on the way in is a little bit more controversial, but perhaps disinfecting them is. So those things are controllable. And the feedback that we've been getting is that actually the seeds are the biggest challenge. And that's really interesting for us and for the people like the vertical farms, where
Yeah, exactly.
actually allowing them to get rid of all the pathogens means that they can really focus on delivering the varieties that have the best flavour rather than the best disease resistance.
Absolutely, yeah. David, did you have any comments on this question?
Our technology can certainly work in terms of infrastructure, but we've not done any testing on soil, so I couldn't comment on that, I'm afraid.
Okay, no problem. Debbie, welcome back. Can you hear us all right?
I can hear you. Can you hear me? And am I?
That's great. That's great. And that's just in time for a question that's come in for you, Debbie. So are you ready for us? Obviously, a lot of these technologies are around preventing microbial presence or growth, but obviously refrigeration is another one, and it's something we're all thinking about a lot. We want the vaccine that's at the -4 or the +4 or the -80. So Debbie, does the kind of research that you've been doing, will that obviate the need for cold chain storage and management? Can it be an alternative to, or is it complementary to? Where does it sit alongside the refrigeration story?
Okay, no, that is a very good question. So I think this technology, the ozone technology, as well as other technologies that we look at, they would never take away the need for the cool chain, but they can give you a situation where you can use slightly higher temperatures. And they can provide an insurance against the problems of variation in temperature. So there's a balance. If we have a whole range of technologies aiming to extend shelf life, reduce rots, etc., then they can go in harmony and reduce our needs for energy, frankly.
Yeah, I wanted to come on to the energy conversation, and David, you were talking about the reduction in energy and I guess you're not having to heat the water, and we're thinking quite a lot obviously about how the whole sector needs to reach net zero. But I think 2040 was the NFU's challenge. So is there a kind of life cycle analysis of how we look at these processes alongside existing practice? You know, you did some benchmarking around the reductions that your technology offered. How much further can we go on delivering on those metrics around net zero? Could you turn your mic on, please?
Yeah, one of us would do that eventually, wouldn't they? So forgive me, everyone. Yeah, so I wouldn't look beyond what we're currently doing. Our thinking around carbon reduction and energy reduction is largely driven, as you point out, Belinda, by the reduced need to heat the water, which is a substantial cost and energy drain. How much further we can go beyond that, I don't know. I think for me, it's a case of piecing together multiple technologies and putting together that ecosystem that you talk about at the beginning that'll make the difference. And I think what Ralph and Debbie talked about, you can see, very complementary technologies throughout the food chain. Very interesting.
And are we seeing that in the agri-food sector? Are we seeing those kind of technology bundles or stacks, or however we might like to describe them, or are they all being developed in isolation? What's your sense for the industry?
My sense at the moment is that they're largely being developed in isolation. I'm seeing some investors at scale who are looking to piece together some of those subcomponents and build more of a holistic approach. And I'm certainly seeing a a big growth in the appetite for sort of agri-tech investment. So I think it would naturally, if you think about the evolution of new technologies, they tend to start with innovative science-based solutions that spawn embryonic businesses, and then at some point you get that consolidation either by existing players that are enabled or impacted, or the beneficiaries of these technologies who look to bring them in. Lots of venturing going on, isn't there, in the food industry now? So I think it will come.
Well, shall we look at the other end of the value chain? Debbie, you're not exactly at fundamental research, but your work is applied. Are you seeing, how does the industry seem from your perspective and linking the research and end users?
Okay, so as you say, we're not really basic scientists. We are very applied, which I'm very pleased to be in that space. I was going to react to what you just were asking, David, previously, that we as scientists, the people who are testing the technologies, we're much more in a position to see how the technologies are fitting together. It's not, we're not relying on a particular technology working, so we're seeing how they balance. And I would say not only is it possible to see that certain technologies can work in synergy with others, but we're also learning how to monitor what's going on during storage, and therefore more easily able to balance the inputs and reduce the energy, because we can see how the produce is behaving.
Okay,
and that makes sense.
Yeah, no, absolutely. And are they ongoing projects that you've got, because you're funded by grants and industry projects, aren't you?
We have funding across the research councils, AHDB, Innovate, and consultancies. So yes, I would say we have a suite of projects looking at monitoring the produce by its respiration, by the volatiles that they're giving off, and even by looking at photosynthesis, chlorophyll fluorescence for some green produce. And all these come together to allow us to see how stressed.
I think we've lost Debbie there for a second. So I'm going to carry on. So we'll have to just move on from that question. Sorry, Debbie, we lost you for a second there. So we'll just change gear a little bit. What I wanted to just pick up on something that David was talking about around the evolution of the industry. And I want to talk, if I may, about scalability of the different technologies that we've heard from. And Ralph, shall we start with you, because you've got quite a clear roadmap as to what that scaling of the Aurora Z10 is going to look like. How much of a challenge has that been, and how big does it need to get to be commercially viable?
You know, it's a really interesting aspect of what we've been doing. It ties a little bit into your last question, in that plasma processing of seeds is something that cutting edge research has been working on for 2 or 3 decades. The seeds industry has been aware of the effect of plasma on seeds, but equally in research it's been possible to do a teaspoonful of seeds at a time in high vacuum or in an expensive noble gas or whatever, and it just simply wasn't scalable to production sizes. So we started with a lab demonstrator that would process, it's about the size of a Coke bottle really. It would process a very small amount of seeds, but it proved the concept of creating the plasmas in cold, normal air. And we mapped it out, and we did a lot of simulation, a lot of modeling to say we could go to 10 litres, we can step onto 100 litres, we can understand how the seeds will be, as you saw when they were tumbling in the drum, that very slow process of mixing them, to make sure that it scaled out. And the maths that we've done says that without stretching the assumptions too far, the systems out at 600 litres should be fine. We think the 2,500, 5,000 litre systems should also be fine, but that's getting to the limit of our assumptions. But the interesting thing is the amount of effort that's gone in to prove that scalability. The 10 litre machine is quite interesting in that it's pulled in 2 directions. If you were processing tomato seeds, it's actually too big. Because tomato seeds are so expensive. They're worth £100,000 a kilogram for tomato rootstock. So you are not going to put £100,000 worth of seeds in one batch. You're going to split it up into smaller batches. Equally, if you're processing carrots, you're probably wanting to do hundreds of kilograms a day, probably tons per day. And so we've got to look at the scaling up. I think the reality is each of the machines I presented is targeting part of the market. So if you look at sugar beet, it would fit in one of the larger machines. Wheat is probably beyond the 5,000 litre machine, but flowers are perhaps in the 10 litre machine. I think a lot of the work that's going on in controlled environment is perhaps the 100 litre machine, with some various options and accessories that we have planned for that. So each one of them has its place in the market. The 100 litre is for mainstream producers who aren't into tomatoes and peppers. The 100 litre is probably the entry point, and we expect the 600 to be the big volume runner over time. But each one of them has its niche.
Sure, gosh, you really thought about that one, haven't you? David, talk to me about scaling up of your technology. I mean, you talked about it in major kind of food processing facilities. Would it be applicable in, say, a poultry unit or a slaughterhouse or other contexts? And what are your plans for that?
Yeah, and that makes sense, but it absolutely is relevant. We've got the BPR product type approvals for doing that, and our sort of equipment range. It's interesting listening to Ralph talking about their equipment range. We have a similar equipment range, ranging from what we call the LQ, which is about the size of a domestic washing machine, and will deliver sort of 200 litres of ready-for-use product a day for a small food service operation, potentially an agricultural application, all the way through to I think that our biggest capacity from a single machine would be 150,000 litres per day. So a lot. It shows you the amount of water that these operations use, and sort of all points in between. Really, it's the technology we've landed on now is I think it's fair to say infinitely scalable within that range. Frankly, it's been used in much bigger applications outside food. But it's so we put together the product range. Again, I like what Ralph's doing about starting with the smaller applications and then building a track record from there. We've already got some pilots that we've completed and are underway with some fairly major food manufacturers, and there's there's a lot of interest. So I think one of the challenges of scaling up for any business is to make sure you plot a course through all of that you can sustain in terms of your organization capabilities, the supply chain you need to put together, and frankly, the financial wherewithal. It's particularly when you start looking beyond the UK, it doesn't take long to burn a lot of time and cash flying around the world for people who on the face of it are very interested.
Absolutely. And Debbie, how involved do you get in that scale up conversation when it comes to talking to businesses?
So spatial scaling up, I'm talking about in this case, rather than financial scaling up, is very important for the first application that I talked about. So here we were talking about low levels of ozone within a store. So we could, in small scale, it's very easy to make sure that you've got good distribution of ozone. In a large store, the real challenge is, are you sure that you've got ozone everywhere through the store? Imagine a pile of pallets of tomatoes, say. If you put ozone into the store, are we sure that we've got the ozone in the middle of the pallet? So that is absolutely vital, that we can do that, that upscaling. So we do try and be as involved in this as possible. It's important for us as scientists to understand the limitations of what we're doing at small scale. And it's important for us to be able to see what happens as you upscale. With ozone, it's particularly difficult to be able to measure because of the measurement methods require sampling and physically taking samples through a UV chamber in order to measure. So there are challenges, definitely.
Can you use, this is probably a ridiculous question, can you use the same kinds of mechanisms that you would use with fogging chemicals in potato stores?
No, I don't think that's a ridiculous idea at all. For ozone itself, not sure. I mean, at the moment, the way it's been working with stores is that usually there are 1 or 2 or 3 inlets. People have been working on activated water, so which is more akin to what David was talking about, and misting in that way. We haven't been involved in trials on that specifically. So no, that's a fine question. Well done, Belinda.
Okay. There've been a couple of specifics come in, still on the big scale, and Ralph, you talked a little bit about wheat, and there has been a question come in about the potential to use it. I guess you can use it on wheat, whether it would ever be viable or desirable at the kind of volumes that are needed. Have you got any thoughts about its applicability on real broadacre wheat, oilseed rape, sugar beet seeds, that kind of thing?
Sugar beet's on the roadmap for something that we want to be doing in a couple of years' time. But of course, that's a stepping stone towards wheat. The current architecture that we're using of having a drum filled with activated air, I think wheat outgrows that architecture. So we have some ideas for what we would do next to get to that sort of scale, to build a machine that's more of a flow-through type of architecture rather than a batch processing architecture.
Yeah.
So I think it's several years away. And there's a really interesting thing that happens in the seeds market is the smaller the batch, the more the seeds are worth. So, you know, we took the example of tomato a moment ago. You know, 1 tomato seed is probably worth a couple of kilograms of wheat. And so there's a double draw towards the more specialist crops. We very much focus on fruit, vegetables, and we will grow out towards the cereals later. But it could be a couple of years before we get to it.
Okay. There was one other question while you have the talking stick, Ralph. Bring in mind Debbie's comments about the reactivity of ozone and the challenge it just wants to interact with everything it meets. How much of a constraint was that in designing the Aurora Z10? Did you have to think very carefully about what you made it out of so that it didn't eat itself?
Oh yes. And we found lots of things that it shouldn't have eaten that it did.
I'll give some scare stories.
Yeah, those embarrassing moments where you discover that a material that's got, for example, some of the electrical insulation that was supposed to be resistant that wasn't. The cables that are color coded, you know, red and black. You run the machine and they're both white, and it's like, well, you know, it's the classic James Bond thing. Which wire do you cut? So it's been very interesting. The drum is made out of 316L stainless. The last time I saw that was at Sellafield for containing nuclear waste. It is quite common in the sort of the biological industry. So material selection has been a voyage of discovery as of things that we can use, particularly around things like bearing seals, because of course it's not just a static drum, it's a rolling drum. Yeah. So yeah, there's a lot of know-how gets built up in those areas.
I can see you nodding, David. It feels like you might have some war wounds as well to talk about.
Yeah, yes, both within sort of current operation. When Ralph talks about seals, I've got a background in marine as well, and seals are a problem in anything that you're trying to keep the water out of. But yes, the challenge for us is to make sure that that we and the operators of our equipment flush the food production surfaces properly. If they do that, then there's no residue that's a problem. But it's always a question we get asked.
Sure. There's a question that's come in just now, actually, for Debbie. For ozone flushing fruit in punnets, Debbie, how long does this take per punnet? And do you need specialised punnets and film to be able to use that technology?
Okay, so so far we've been using an experimental system. For our convenience, we basically took punnets which had already been packed and sealed, and then we injected a high concentration of ozone. That was a compromise because we didn't have a whole packing line to play with. But with the results that we've got, we will have a whole packing line to play with, in which case, rather than taking pre-packed punnets and injecting, we'll actually have ozone being flushed through at the start. So in that case, speed-wise, it won't slow down the packing line. So far, we've only been looking at modified atmosphere packs, so basically sealed packs. So the advantage of that is that the ozone will stay in the pack. As I said, it's very short-lived, so it will only be a matter of minutes before it's disappeared, but it stays in the pack, and therefore you've got the full action of that ozone. What we haven't done yet is try out the same with, for example, macro perforated packs. That would be a different engineering issue, and I'm told engineers are very optimistic people, that if it's just a matter of an engineering issue, as in making sure that you contain the ozone for a period of seconds or whatever, the engineers can always find a solution to it. I'm just a poor biologist, but I can see that with the macro perforated situation, there would have to be an engineering solution to enable that to be contained for long enough until the ozone had naturally dissipated or naturally reacted. Sure. So quick answer is quick. To some extent, special punnets, because we're focusing on the MAP, the modified atmosphere punnets.
So just an engineering solution.
Just an engineering
Stay
solution.
late in the lab one night and sort it. Absolutely.
Yeah, no problem.
There was a question came in again for you, Debbie. Will it work for dairy? You want to be the person to try?
So I suppose, I guess what immediately goes into my mind is, well, first of all, let's I don't know what sort of dairy you're talking about. Let's say you want to decontaminate milk or something. What I don't know is what chemical effect the ozone would have on the milk. So I don't have the expertise to answer that question, because it may change the chemistry, the taste of whatever it is that you're treating. Whereas the sort of produce that I'm working on with, everything has basically a surface which is there to protect itself from the environment. So everything that we work with already is protecting itself from this extremely dangerous 21% oxygen in the atmosphere. So it has that natural protection already. And even then, it's not all safe with the ozone that we're using. As I said, the calyx of the strawberry doesn't survive. So sorry, I don't have the expertise. I can't answer that question.
But that's an interesting point, because also with Ralph, so your seeds have got that nice protective seed coat, whereas David's technology is much more kind of exposed to your actual product, I guess. Is it? You don't have the luxury of that nice biological casing, do you, David, with the kind of material that you're working with?
Well, I mean, we're treating the food manufacturing equipment and the facilities, the infrastructure, not the product itself.
Actually, it doesn't see the product.
So,
no. So, steel work is tolerant to it. Yeah. Okay, so I'm going to issue a call to the audience, so that last chance for any questions in the chat. And just in wrapping up, I'd like to ask each of our three speakers what would be a key message to a particular key group of stakeholders. And you can choose your stakeholder. That might be policy, it might be regulators, it might be growers, retailers, food manufacturers, whatever. So what is your key message that you would really like to be heard by this particular stakeholder group? and we'll go in the order in which you spoke, which is Ralph, Debbie and David, just to give you a little bit of time to prepare your answers. So if there's no more questions in the chat, we'll have one more, the final closing question. So Ralph, we'll start with you. What would be your key message to which group of key stakeholders that would really impact the growth of the business and the adoption and acceleration of the technology?
I think I would go to the regulators, particularly the international regulation, where at the moment plasma treatment of seeds is being treated as a physical treatment in the same way as the hot water dip, or if you expose them to ultraviolet. And just confirming that globally is an acceptable approach, and that this is an acceptable approach for shipping seeds, for example, into Australia, where there are approved disinfection processes. If you want to ship in, I don't know, tomato seeds, then you have to put them in this particular process or that particular process. Well, accepting that the plasma treatment is at least as effective as either of those, and authorising it for these intercontinental shipments would be a big step forward for us.
Okay, noted. I hope they're listening. Thank you, Ralph. Debbie, what would your key message be, and to whom?
Okay, so I think today my key message would be to the growers and the processors. So in my line of business, we are in the business of assessing a number of technologies and developing new technologies. Although there's some wonderful technologies around, there's quite a lot of misinformation as well. And I think one reason that there is misinformation, or that it is allowed to proliferate, is that because there's a lot of competition between growers and processors, there's not as much sharing of information and expertise as there could be. And I suppose, you know, at this point, especially when we're about to have the vote on the levy for AHDB, that is a situation where there is a forum in place for sharing information and doing joint studies. I don't think it's done enough, but I would like to encourage growers and processors in the industry to look at ways in which they can share information, and that we can grow the knowledge as we go into the future. Of course, in some cases there has to be competition, but we want that body of knowledge to move forward for the good of the whole industry.
Absolutely, great call to arms there, Debbie. Thank you. And then finally, David, what would be your key message, and to whom?
Yeah, thank you. I think for me, I'd probably focus on food manufacturers and retailers, perhaps not surprisingly for what we're trying to do. And for me, I think there's an inherent conflict between what retailers and manufacturers need to do and want to do to deliver the sustainability that is behind everything the speakers have talked about today, and to drive down carbon, to drive down energy, water consumption, improve food productivity, whether that's through what we do or seed treatment, for example. And the problem is that to get those technologies away, to allow those technologies to scale up in a meaningful way, requires the right environment and the opportunity to test and retest and double back and fail in many cases, to learn and move forward again. And I mentioned inherent conflict, that for food manufacturers in particular, to try to do that in an environment where they're dealing with inherently perishable product that has to get out of the door, and very demanding supply chain partners with strict delivery slots that they have to hit, and very, very tight margins, it's really hard for perhaps the production manager on the spot to do both at the same time, and to even have the headspace to do both at the same time. And that's even without the current challenges. So I guess the message is there a way of compartmentalizing those two really important priorities, the short-term need to deliver cost-effective, timely food and margins, and the need to experiment to hit the longer-term targets that we're all aiming for?
Sure, great point. Well, thank you so much for sharing your thoughts, your technologies, the insights to the work that you do. If you could just stay with us while I just tell our audience about a couple of other things that might be that are coming up that might be of relevance. We've talked quite a bit this afternoon about net zero, and we've got an event coming up for our members with Method, which is an international design consultancy that's looking at how to achieve net zero by 2040. We're going to be fast forwarding into the future and working together to look at how we might reach net zero as an agri-food industry. You can see some of the slides, some of the events we've got coming up. The other one that hopefully might be of particular interest to this audience would be our vertical farming event on the 25th of February. You've heard some of the technologies we've heard of today may be relevant for the vertical farming sector. So all those are coming up. You obviously know our website because you found how to register for this event. So you'll be very welcome to come to any of those and indeed subsequent ones. So with that, I think on behalf of the audience, may I thank David and Ralph and Debbie for giving up your afternoon to talk to us this afternoon. It's been an absolute pleasure. It's been an inspiration to hear that there are these alternative innovations that are coming through and hopefully are set to transform the industry. So with that, can I thank everybody for joining us this afternoon and wish you a pleasant evening. Thank you very much.